Hello everyone. On this video we will be going over piecewise functions. Okay. Now what's the main idea behind a piecewise function? Is a piecewise function can have several functions on the same xy plane. On the same xy plane, but they are all f of x. Alright, so to kind of help you visualize it, let's take a look back at some of our basic graphs. So if you remember, f of x equals x or y equals x. The graph of that if you draw your x and y axis, it's kind of just a diagonal line through the origin. Okay, so this is y. I can say y equals x or f of x equals x. Okay, so we have our f of x equals x. And if you kind of think back a little bit, remember your f of x equals x squared. Okay, so if you remember, that's just really a parabola, again meeting up, having your vertex at the origin. Okay, so this is your f of x equals x squared. So what we're going to do is we're going to kind of combine those two graphs onto one graph, just in pieces. Okay, so go ahead and scroll up a little bit. What if we have f of x equals, let's say x, whenever x is less than 0, but f of x is x squared when x is greater than or equal to 0. Okay, so what we're going to do is just kind of move that over here, go down a little bit more. Okay, so if we draw our x and y axis, we can graph our piecewise function onto here using those two functions there, our x and our x squared, since we have our x and x squared. Okay, so remember, this is x equals 0, and you have your negative numbers and you have your positive numbers for x. Okay, so for x less than 0, f of x equals x. Now remember, this is our f of x equals x. So what that's telling us is that, let me get a piece of paper to kind of cover that up. For our x less than 0, we're just going to use that part of the graph. Because remember, where x is equals 0 right here, that's the only part that we're using f of x equals x. So f of x equals x kind of goes right here. And it stops at x equals 0. Okay, so we're only using part of that one. Alright, so now for x greater than 0, we have f of x equals x squared. So that means to the left of 0, we're going to be x, but to the right of 0, we're going to use this one. Okay, so we're going to kind of cover that up. And to the right of 0, we're only going to use that right part. Oops, let me kind of clean that up a little bit more. good enough. Hopefully you get the idea from there. Okay, and that is a piecewise function where you have x squared greater than 0 and you have f of x equals x for less than 0. That makes your piecewise function. Alright. So, if you are still writing or drawing, feel free to press pause. But we're going to go ahead and move on to our first example. Okay, so let's say, for example, if we have the piecewise function f of x is equal to, and make our little bracket there, x plus 1 when x is less than 5, and f of x is equal to x squared plus 4 when x is greater than or equal to 5. Okay, so you want to find, let's say for problem A, f of 3, for problem B, f of 7, for problem C, f of 0, and for problem D, f of 5. Alright, now when approaching a piecewise function, those little barriers there, or your 5, this is the most important part. Okay, and I'll show you why. Those constraints is what you're going to graph. So you're always going to start with a graph. Okay, so here you have 5 as your, I guess you could say your endpoints. So we're going to go ahead and graph that. And here we have our 5. Okay, now here you have x is less than 5. When x is less than 5, your f of x is x plus 1. So for less than 5, f of x equals x plus 1. Now for greater than or equal to 5, x is greater than or equal to 5, your f of x is x squared plus 4. F of x equals x squared plus 4. Okay. Now, solving each one of these all depends on where that x value falls. So here, 3, 7, 0, and 5, that determines which one of those f of x values you're going to use. Okay, so let's start with problem A. F of 3. Okay, so in this case, x is equal to 3. All right, so what do we know about 3? Is 3 less than 5, or is it greater than or equal to 5? Okay, so we can all agree that 3 is less than 5. So 3 is less than 5. So the f of x we're going to use is x plus 1. Alright, so to find our f of 3, that's going to equal 3 plus 1. Just replacing the x with 3, which is 4. Okay, so f of 3 is equal to 4. Alright, so let's go ahead to problem B. f of 7. Alright? So, in this case, our x is equal to 7. So you just have to ask yourself, is 7 less than 5? Or is 7 greater than or equal to 5? Okay? Once again, we can agree that 7 is greater than or equal to 5. So 7 is greater than or equal to 5. So that means this is the f of x we're going to use. So f of x is equal to x squared plus 4. Okay, so now we go ahead and plug in our 7. So that means our f of 7 is equal to 7 squared plus 4, which is 53. So f of 7 is equal to 53. Alright. So if you think you have it, go ahead and press pause and try C on your own. Alright, so I'm assuming you've pressed pause and worked out problem C. Let's go ahead and verify your answer. So f of 0. Again, you have to ask yourself, is 0 less than 5 or is it greater than or equal to 5? Okay, we know that our x equals 0 is less than 5. So since 0 is less than 5, that's the f of x we're going to use. So f of x is equal to x plus 1. So to find our f of 0 is just going to be 0 plus 1, which is 1. Okay, so if you think you got the hang of it, go ahead and press pause and try problem D. Let me clean up that D a little bit. Alright, so assuming you've pressed pause and you've already worked this one out, let's verify your answer. So to find f of 5, we know that x is equal to 5. So again, we just ask, is 5 less than 5? Or is 5 greater than or equal to 5? Okay. So we can see here that it's greater than or equal to 5. Okay, so we know that our x is greater than or equal to 5. So that means this is the f of x we're going to use. F of x is equal to x squared plus 4. So to find our f of 5 is just 5 squared plus 4, which is 25 plus 4, which is 29. Okay, so once you understand that, I'm just going to scroll up a little bit. Once you understand that everything you do revolve around your constraints, you'll be okay. Alright, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so for this one, we're going to kind of work around a graph. Okay, so let's say we have our XY axis. We have our X and we have our Y. Okay, so let's say we have our 1, 2, let's say -1, say -2. And for our x-axis, we have a 1, 2, 3, and I'll move it up to 4. And let's say for this side we have -1 and -2. Alright, so for this one, let's say that our graph goes from here to here. And let's say for this one, our graph goes from here to here. And let's say for this one, our graph goes from here to here. Just horizontal lines. Alright, so using this graph, this piecewise function, we want to find, for problem A, f of 0. For problem B, f of 3. And for problem C, f of -1. Alright, so starting off with our problem A, which is f of 0, it lets us know that x is equal to 0. Okay, so when x equals 0, what part of the graph has a y value? Well, you can see here, this one stops before it gets over x equals 0, and this one isn't over x equals 0. But we see here, when x is equal to 0, y is equal to -2, or your f of x is equal to -2. Okay, so we know that's equal to -2. Because when x is equal to 0, y is equal to -2, which gives you f of 0 equals -2. Alright, so let's go ahead and work on problem B. We want to know f of 3. So in this case, we know that x is equal to 3. Okay, so when x is equal to 3, your y is equal to 1. Okay, so when x is equal to 3, y is equal to 1, which means that f of 3 is equal to 1. Okay, so you always want to look for your x value and see where on the y plane, going up or down, do you have a value. You can see here, when x is equal to 3, you only have that one y value. You don't have any place where you cross the graph below it, just that one above it, and that just happens to equal 1. Okay, so let's look at problem C, f of -1. Alright, so what I want you to do is go ahead and press pause and take a couple seconds and find the answer to that one. Alright, so I'm assuming you've pressed pause and you've worked this one out already. So let's go ahead and verify your answer. Okay, so you should have gotten for f of -1, -2. Okay. Why is that? Because when x is equal to -1, it wouldn't be +2. Let me move that down. It wouldn't be +2 because you have that open circle. Okay, at x equals -1, you have the closed circle, which means it actually equals -1 when coming from the right. I mean -2, sorry about that. Okay, so the first thing you want to do is notice the closed circle. when x is equal to negative 1. We know that y is equal to negative 2, which means that f of negative 1 equals negative 2. Okay, so that's how you would solve or approach a piecewise function if you had just a graph and you had to figure out those specific values. Okay, so the graph can look like anything. This is just one example, but the approach is the exact same. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and do another example just to make sure that you have everything down. All right. So what if we wanted to find f of 2 for, say, f of x equals negative 2x when x is less than 1, x plus 2 when x is between 1, less than or equal to x, and it's less than 2, or x squared plus 2 when 2 is less than x. Alright, so once again, whether you have 2, 3, or 4 piecewise functions, it doesn't matter. Your constraints will always be where you start. Okay, so we're going to go ahead and draw our number line. But in this case, you have 1 and 2s. Okay, so we go ahead and just put our 1 and our 2. Alright. So we know here that x is less than 1. Okay, so when x is less than 1, we know that our f of x equals negative 2x. Okay, what about between 1 and 2? Okay, when x is less than 1 is less than or equal to x, and x is less than 2, that means x can equal 1 because it'll be less than or equal to, but it can't equal 2. It has to be less than 2. When that's the case, our f of x is equal to x plus 2. You can see that. But, quick note here, you can switch these two around. Okay, so quick side note, 2 is less than x is the same as saying x is greater than 2. If it's pointing to the 2 here, when you switch it around, it still has to point to the 2. That's how you know you have it correct. You can't switch it around and magically the little symbol is pointing to the x. If it's pointing to the 2 here, if you switch it around, it still has to point to the 2. Okay, so that's how you know you did it right. Okay, so in this case, when x is greater than 2, your f of x, nope, greater than or equal to. Sorry about that. That should have been less than or equal to, because it wouldn't have made sense any other way. Then our f of x is equal to x squared plus 2. Alright, so we want to know how to find the value for f of 2. So that should be equal to there. There we go. Well, we do it the same way that we've done it before. When x is equal to 2, remember here it can't equal 2. But here is greater than or equal to 2. We see that 2, our x equals 2, is greater than or equal to 2. So that means your f of x is equal to x squared plus 2. So if we want to find our f of 2, that's going to equal 2 squared plus 2. We just replace the x with the 2. So we have 4 plus 2, which is 6. Okay, so that gives us our answer. Alright, so hopefully this made sense, and I'll see you on the next video.